Good evening everybody, how are you? So today we are going to discuss about chemical equilibrium. So chemical equilibrium, how can you find out? Suppose one reaction is there, that is A plus B in equilibrium with C plus D. So how can you find out Kc value? So Kc value we can find out C concentration into D concentration by A concentration into B concentration, you know that. Then Qc, coefficient. Qc, how can you find out? Same C concentration into D concentration by A concentration into B concentration. Okay. Kc, Qc are same. So it will changes with temperature. Okay. Changes with temperature, not changes with temperature. Understood? Qc will be depends upon temperature, but Kc will not depends upon temperature. How can you find out Kp value? So Kc is find out like this, Qc is find out like this. How can you find out Qc value? Now, how can you find out Kp value? Kp value is equal to partial pressure of C into partial pressure of D by partial pressure of A into partial pressure of B. This is the Kp value. So there is a relation between Kp and Kc. How can you find out Kp and Kc relation? So Kp is equal to Kc RT, okay, delta N. Okay. Here delta N is number of moles difference. Number of moles difference. So how can you find out number of moles? I will give you one example. You can find out. Okay. Next one. Take an example. N2,3H2 gives rise to 2NH3. Tell me delta N value. Delta N value always we have to calculate number of moles in product side minus number of moles in reactant. So now tell me what is the number of moles in product side? 2. Number of moles in reactant side is 4. So what is the value? Minus 2. Now tell me Kp Kc relation. Kp is equal to Kc RT delta N. So Kp is equal to Kc RT delta N means how much? Minus 2 is the answer. So this is in inverse proportion. So here Kc is greater than Kp. Okay, suppose I given this compound 2NH3 gives rise to N2,3H2. Delta N means number of product minus number of reactants. Tell me 4 minus 2 is equal to plus 2. So Kp is equal to Kc RT. Delta N how much? Plus 2. Here Kp is greater than Kc. Okay. This is called forward reaction. Understand? Suppose delta N is equal to 0. This is in equilibrium. You have to remember. Don't forget. If delta N value is 0, this is in equilibrium. The reaction is in equilibrium. Okay. Next, we are going to discuss about Le-Chatelier principle. Le-Chatelier principle. So, we are going to discuss about Le-Chatelier principle. How can you predict the Le-Chatelier principle? So, here some more basic concepts are there we have to remember. Totally lesson has this concept only. So suppose you take any example, N2 plus 3H2 gives rise to 2NH3 here. Okay. if pressure is increases, reaction goes towards less number of moles. Reaction goes towards less number of moles. Here tell me which has less number of moles. Product side has less number of moles. Now tell me equilibrium shifts towards forward reaction. Understand? Okay. By pressure concept is over. Now if concentration is increases, this is first one. Second one is concentration changes. Concentration changes. If I increase N2 concentration, so formula is like this. If I increase N2 concentration, so now tell me, if I increase or adding one more N2 concentration in the reactant side. Now tell me, comparing product side and reactants, which has more concentration? This has more concentration. It means in reactant side concentration is more. So we need, this should be in equilibrium. So it has more concentration, it has less concentration. What is the, so if you want equilibrium condition, how can you adjust this one? This concentration, some concentration will goes towards forward and form product. By this equilibrium will be balanced. So finally N2 concentration increase, forward reaction takes place. Same here also same. H2 concentration if increases, here also, here H2 is concentration is less. That's why concentration should be shift toward forward reaction. H2 concentration increase, forward reaction. Here NH3 concentration is decreases. If NH3 concentration decreases, it means here N2 and H2 concentration is more. That's why to balance this one, just this concentration should be shift toward this side. So here we have to give reaction towards forward reaction. Just opposite to this one. So if you decrease N2 concentration, H2 concentration, if you increase NH3 concentration, how happen? 3 are backward reaction. It means like this, backward reaction takes place. Understood? Okay. Okay, now we are going to changes in temperature. Okay, third one is change in temperature. So first N2E plus 3H2 gives rise to 2NH3 concentration. Suppose delta H is positive, this is called endothermic reaction. Endothermic means we have to use high temperature. Okay, high temperature we have to use. Suppose delta H is negative, this is called exothermic reaction. We have to use low temperature. Okay. Suppose if I add delta H towards reactants like this, 2NH3 like this. Delta is positive here, adding means endothermic reaction, we have to use high temperature. So temperature is increasing. Already delta H is there temperature which is equilibrium with NH3 concentration. So here what happens? Now we are increasing temperature. To balance this one, temperature or this delta H should be shifted to this level. So forward reaction takes place. Understood? Forward reaction takes place. Same thing, N2 3H2 2NH3 minus delta H is there. It means delta H is there. If delta H comes to this part, delta H plus delta H is there. Same Here high temperature, here low temperature. With low temperature, forward reaction takes place. Understand? Forward reaction takes place. These are the main concept. If in a reaction difference in number of moles is 0, there is no change in equilibrium shift. If delta n 0, okay, delta n is 0, okay, no change, okay, no change in equilibrium. Whatever it may be, if you increase pressure or decrease pressure, there is no change in equilibrium shift. So now fourth point is adding of inert electrolyte, inert gas. If we add inert gas in the constant volume, okay, add inert gas in constant volume. Here what happens? No change in equilibrium shift. No change in equilibrium shift. Okay. If pressure is constant, adding inert gas in pressure constant, okay, equilibrium shift moves towards more number of moles. Okay, adding of inert gas. If you add inert gas at constant volume, there is no change in equilibrium shift. If you add a inert gas in presence of pressure constant, so equilibrium shift towards more number of moles. These are the main concept observed in chemical equilibrium. Okay, so this is the one part. So I will tell another part in next class. So please subscribe my channel. Why? Because if you subscribe, I will give you more information about any topic or anything. If you want any topic, if you want trick, just message me or in comment box. I will read each and every comment and I will follow you. Okay, thank you.